Hi, and welcome to another edition of Podcasts for the Future. My name's Tim Crispin, and today I'm joined by Justin Fiaschetti, the CEO and co-founder of Inversion Space. Justin has spent the past few years working a variety of different space jobs leading up to the founding of Inversion, which actually was birthed in late 2020, went through Y Combinator in mid 21, just closed its $10 million seed round last fall, and is now in the process of scaling up and preparing for some of its demonstrator missions next year. Justin actually is relatively early in his career. He went to Boston University for a mechanical engineering degree with an aerospace focus, but ended up putting his bachelor's degree on hold because in his senior year, he realized there is really the market timing and opportunity to take this idea of returning goods from space in a reusable, rapid way, that now is the time to do it. And so he sees that opportunity along with his co-founder. And as we've seen over the past year, it looks like they were right on the money in terms of the timing of this and the market potential. So without further ado, let's jump in. All righty, great to have you here, Justin. Thanks for coming on to Podcast for the Future.
Yeah, thank you so much for having me.
Yeah, it's exciting having a chance to chat with you. We'll get to talking about Inversion and what you're doing now, but being somebody that has watched startups from the outside for quite a while, it's pretty cool being able to talk to a pseudo celebrity in startup land because you're a successful Y Combinator grad. So that's pretty cool. What was that like?
Yeah, I appreciate it. And I wouldn't say I'm anything of a celebrity at all yet, but I appreciate it. Yeah, Y Combinator was fantastic. Inversion, we're focused on building low-cost space capsules for returning cargo back to Earth. Kind of one of the first companies focused on reentry and return solely. We've seen a lot of great launch companies come online to basically open up space as a sector that we can actually do things in. And myself and my co-founder, Austin, we decided, hey, we need to focus on this sector that hasn't been addressed, which is return. And so we applied to Y Combinator we actually applied on December 23rd of 2020, which is about 7 days before the batch started for the winter 21 batch. And the deadline was back in September. So we were about 3 months late on the application, but we said, hey, we might as well send in the application. And while we weren't able to get into that batch, they said, hey, we're going to roll you over into your application over, and we'll look at you for the summer batch. So around the end of February, we got a call saying, hey, we want to interview you guys for the batch. And we went into the interview. The Y Combinator interviews are incredibly tough. It's about 10 minutes of just very intense questioning. And so we prepped for that we found out about it, I think about 3 days early, and we prepped up for that for the entire day, every single day up until it. And then we did the interview. We got the call that they wanted to let us into the batch, which we were incredibly excited about. And I think it's just a testament to Y Combinator seeing the future of space, seeing the different use cases that are possible, and willing to take risks on that kind of thing. So then we started the batch over the summer of 2021. So we started in June, the June timeframe. And it is, as anyone will tell you, it is one of the most productive times a company will ever, from just the velocity you're moving, the pace you're moving, the amount you're learning. And it was really helpful for myself and my co-founder, Austin, because we're engineers by trade, right? So learning that business side, learning the fundraising side, just a really incredible experience. And they just announced a new deal, a new standard deal for Y Combinator companies, upping the amount of money they give, which is really exciting.
Oh, that is cool. Yeah, no, that's awesome. Yeah, I want to hear more about Inversion, but I wanted to start by talking about where you got your start, because it definitely seems like a mix of what you would expect and not so much. Like, you went to Boston University for mechanical engineering. My dad's a mechanical engineer, so I'm obligated to make jokes about civil engineers. But yeah, what was that like coming out of mechanical engineering for aerospace and then starting work in the sector?
Yeah, started my general excitement and experience in building things started in high school, where I was really into woodworking, fine woodworking for furniture and art pieces and stuff like that. and really got the bug for just like creating something out of nothing or transforming materials into functional pieces of furniture in that case. And that led right into college, where focused on mechanical engineering. Myself and my co-founder, Austin, we actually met each other we sat next to each other at the matriculation ceremony on the first day of college, which was very, very exciting. And we ended up joining the rocket propulsion group at Boston University together, a group focused on being the first undergraduate group to launch a liquid bipropellant rocket to space, so past the Kármán line. And we just fell in love with it from the very first day there of bringing industry level experience down into the collegiate age group, and spent many nights in the lab working tirelessly, designing a lot of great stuff. And yeah, so then I had the opportunity to go to SpaceX down in McGregor and work on test equipment for their Raptor engine, which was a fantastic experience. And then also go to Relativity Space, where I was working on the cooling systems for their Aeon engine. So really a kind of great experience there. And those were both internships. So those were both during college. And then myself and my co-founder Austin, we came up with the idea of Inversion actually in our senior years of college. And we said, hey, this is like really incredible, right? This idea, the market timing's perfect. We spent about 2 months pressure testing the idea, talking with customers, understanding, is this a thing? Will this be needed? And then decided to go full time on it. Finished up one last semester, and then took a leave of absence because I fully believed in Inversion and the mission that we're focused on of making the first accessible return vehicles for both the commercial and defense industries.
Yeah, that's incredible. We don't think about, or at least most people outside the sector don't necessarily think about return. There's a sense that, oh, of course you can get stuff back from space. It just falls to the ground. Like we see astronauts come back all the time. But the sort of mass to orbit and then mass to return is often wildly different. So yeah, talk about sort of what was it that made you realize this is a niche that was unfulfilled?
Yeah, it's a great observation of kind of the difference between launch and reentry as far as even number of missions or total mass. I think last year or the year before, there was about 6 reentry or 6 return missions, while there were 120-ish launch missions. So a vast disparity in that. And that's generally because if you can't go up to space at a high cadence and a low cost, there's really not much of a reason to start breaking, because fundamentally, at first, we need to have higher up mass than down mass. That's not necessarily true long term, which I can get into. But Austin and I were talking one night about what does the future of space look like? We would have these conversations with our friends just because it's fun and all that stuff. But we saw that launch is a pretty solved problem, especially over the next 5 years. A lot of great launch companies, a lot of great talented people going after that space. And there's going to be continuous innovation, which we're really excited about. We also noticed that a lot of the kind of initial things one would think about in doing in space for a one-way trip to space, let's say, of satellite internet or imaging or GPS, a lot of those were, pretty well established, right? Pretty much on the brink of being solved or have been solved. But so we asked ourselves, what is next? What does the future look like? And we saw this vast disparity of, okay, 90% of the value generated in space is brought back to Earth through the return of information and data, rather than the actual return of physical items. And while that is fantastic, and we think that should continue to expand the absolute quantity of information sent back, it's clear that any physical market, as space is a market and as Earth is a market, will have trade between them with physical items. But that can only happen once you have the infrastructure to enable that trade. It's very hard to build a use case before you actually have a way to bring stuff back. Yeah. But there are a lot of promising use cases demonstrated on ISS and across the board, whether that be in-depth research on the life sciences side, or the return of lunar samples or asteroid mining down in the future, or even just fundamentally using space as a transportation layer for Earth transport. A lot of cool stuff coming online.
Yeah. No, and it's as we're starting to hear more and more about everything from 3D printing organs in space to manufacturing in space, that backhaul essentially is the limiting factor right now. And so that's such a cool, and as you said, pretty timely to do that now as we're ramping up launches. Last year, I would bet in no small part getting into Y Combinator was because of that timing. Had it been 3 3 or 4 years previously, they would have been like, cool, all right, yeah, but not enough's going up. So that was amazing market timing there. This is what legends are made of.
I think you hit on a good point of timing, right? Any startup is a combination of the success of any startup is a combination of a number of factors, but one of those is the timing of the market. We've seen a number of companies in different sectors that are just before their time, right? Google Glass is a great example where I think it's pretty clear that an AR glasses will become a thing. And we think that we hit the timing pretty well. Obviously, there's still a lot to be proven out and a lot of work that has to go into fleshing this out. But yeah, I think we're starting to see the market, the space market expand past launch, right? So people are asking, what does the post-launch space economy look like? Whether that, and we've seen all these contracts come out from NASA for space stations and stuff. And one of the biggest things that is limiting for those space stations is re-entry, is the amount of mass and the frequency of mass that you can bring back. Most customers don't want to stay on station for more than 3 weeks at a time. They prefer to bring their cargo back at a higher cadence rather than having to wait for 100 other customers to fly back once a quarter. So yeah, I think the timing was pretty fantastic with YC, and I think that the market timing is great for like the space industry based on the technological capabilities that are available right now. Low cost launch, low cost and small electronic systems, mature thermal protection materials, but also the fundraising market was in a good spot too for that, as well as the customers that we would be flying. They're starting to mature at the same rate we are.
Yeah. No, and that's really cool. And I would imagine as you've gone through the past few months doing the seed fund raising, a lot of that had to also be the market validation and starting to secure those customers. When you look across those customers, are there any that are like, this is really weird? Like, I never thought I would be working with a company that did this.
That's a great question. I think there's a lot of variety in our customer base. Unfortunately, I can't talk too much about the specific customers yet, just because we're still finalizing and are going to be announcing some stuff. But we'd love to come back to announce some stuff with you at some point. But I think there are a lot of use cases I never thought I was going to just have perspective on, right? Being a mechanical engineer. Like, I think the life sciences side of things is a really great opportunity in space where you can do things, you can manufacture organs or you can produce new drugs that I never thought I was going to be working in the life sciences area. But I absolutely love always having conversations with people about those details and about how we can support those. Because, one of the things I'm very excited about is when we are able to bring back the first organ that goes into a human. That's going to be a really meaningful, powerful thing that demonstrates the value of space. I think there's often in the popular media, there's a kind of a discounting of the value of space because it is not here on Earth and helping problems here on Earth. And anyone who's in the space industry knows that there is a lot of value that comes from it, but it's hard to see. So it's understandable why people may not see the value in going high frequency imaging of Earth, right? Sure. It doesn't affect many people on a day-to-day basis. And GPS is such an amorphous thing that it's hard to grasp. But when you're able to see a capsule coming back with an organ that lands and gets directly transferred into a human and it saves their life, that's going to be magical.
Oh yeah. No, and you've talked about these return capsules. In my head, I have this as it's pre-addressed stamped envelope that goes up with the payload. But is that the case? How does this work?
Yeah, great question. So it highly depends on the use case for our capsules on how the ConOps work. The high level is that we're able to carry supplies up and down from space. Where they go once they're in space is a different question. Are they going to a station and then having the supplies brought onto the station, having return cargo brought back? Are they staying in orbit just as a free flyer, right? Are they doing experiments on board our capsule independent of going to the station? Or are you using space as a transportation layer solely, right? Where you're going up and then you're coming right back down to deliver supplies. So there's a variety of different ways that it works. Yeah.
Okay. And so you're mentioning the free flyers. Does that mean you would pre-position essentially empty capsules prepared to bring things back?
So yeah, the free flyer method is basically where we would launch our capsule into space with our payload already inside of it. So the payload would be a life science customer who wants to do pharmaceutical research, for example, research on board of our capsule. Okay. Independent of docking with any other station or system. And then we would be able to bring them back once they're done. So that's highly powerful for any testing or experiments that can't be done on space stations because of the human rating of stations. So high pressure systems is a great example, or looking into anything with radiation, right? There's a lot of exciting examples where having an independent, basically a mini space station is highly beneficial.
Well, and I've seen all the science fiction where you want to keep all those biohazard experiments that make zombie separate from the station. So it's perfect there.
Exactly. Yeah, yeah, yeah.
No, so that's cool. So it goes up, it's up there for a fixed amount of time. You bring it
Mhm.
back. That's a pretty exciting prospect. But you mentioned the docking. Does that mean you do have the capability to dock with, I assume, a variety of platforms?
Yeah, so to highlight, just to give an overview of what the capsules are. So they're about 4 feet in diameter, designed to one, launch on any, and two, be flexible in what they're able to do once they go to orbit.
Yeah,
Launching on any rocket is highly important for a high cadence return system because
yeah.
when you're tied to a single rocket, you're subject to groundings of that launch vehicle, but also the schedule of that launch vehicle. So then once we're in orbit, we want to be able to, one of the biggest places to return supplies from is space stations, right? That
Sure.
is the standard. So we are planning to be able to dock with a variety of different systems.
Okay. Yeah, and with that cadence, what are your projections? I would assume at this point, you actually have probably a pretty good idea of the next 18 to 24 months of what you're going to be doing.
Yeah, in the next roughly 24, our focus right now is actually on a slightly smaller capsule. It's about 1 foot in diameter, and that is our capability demonstrator. That's going to validate a lot of the technology that we're working on to go into that larger 4 foot diameter capsule. So that 1 foot diameter capsule will actually be launching in 2023 and then returning, validating all of our systems and allowing us to build that confidence within the community. So then in that time frame, we're also going to be focused a lot on the design of that larger capsule. And that larger capsule, whose name is ARC, will be flying in 2025.
Okay. Okay. And a lot of, like, Elon was just talking, he has to be able to launch 100 Starlinks at once to avoid bankruptcy or some rather hyperbolic claim. Is there a point in your cadence where we need to have this many launches and returns at a minimum?
Mhm. Yeah, we have those as far as growth metrics, where we want,
Okay.
how we want to be expanding the company, but we're very focused on building a default alive company. So that happens a lot in software, where you're able to have revenue generating systems from the very beginning, whether that's
Yeah,
ads or paying customers. In hardware companies, because
right.
it's large capex to get up to speed. By staying like small and lean as a company, we can actually get to those places and then grow from there. That doesn't mean that we are slowing growth down in any way. It's actually beneficial to growth because it means you can take more risks in other aspects. So staying small to start means that we can have a relatively low number of launches per year and still be quote unquote profitable. But obviously the goal is growth. So we have our internal metrics. One of the big goals is to get to a return per day. Right. Every single day of the year, we're returning something. And that requires multiple use cases within the next 7 years or so to come to fruition. But that's a focus, is getting to that cadence. That we architect our company around that, being able to manufacture these very quickly at a low cost, having reusability built in. Those are really important. You're bringing it back anyway. You might as well be able to fly it again.
Exactly. And where are you looking to be able to land them? Is it, I assume it's not the Amazon Prime drone delivery where this, lands outside the hospital, but
Not yet. Not yet. So the first missions we will be landing in pretty traditional landing sites. They need large radiuses. You want to make sure you're well away from any population centers and stuff like that. The standard places are either off the coast of Florida in the Gulf of Mexico or off the coast of Vandenberg in California. But as we progress, right, one of the pieces of logistics is also ground transportation, right? Once we get the supplies back. So we want to be able to land as close to our customers as possible. So there's a lot of work between now and then to basically have a high confidence interval on where we're going to land. But that's the focus. So to start, we'll be mainly off the coast somewhere.
okay. Okay. So it's not necessarily got a bunch of retro firing rockets, slowing it to a perfect landing, a la Falcon 9 or something.
Not yet. Yeah, it's a similar situation as how Dragon land, deploying parachutes to softly touch down. And like, for example, Starliner is able to land on land, has those airbags, or New Shepard has the retro cold gas thrusters.
Yeah.
It is actually you are able to land on land without the need for a decelerator at the very last second and have it softly land. You just have to be thoughtful on how you do your parachute system to have that soft landing. The long-term focus of the company, especially on a lot of the transportation methods, as accurate as landing as possible. It opens up a number of use cases that we're really excited about.
Yeah, I'll bet. And I'm sure FedEx or UPS will be an exciting partner a few years down the road. Ought to get them in a bidding war to see which one wants to be the first space related company.
Absolutely. Absolutely.
That's pretty cool. Now you're there at your facility outside Los Angeles. Is that right?
So we're in Torrance. So we're like in the South Bay area of
Okay.
LA, maybe 15 minutes from Hawthorne.
Okay. I'm nodding like I know what that is.
There's a great skit on SNL called The California. If you haven't seen it, I highly recommend it.
Okay.
But basically, it's everyone in California and LA always talks about all the different roads that they take. You take the 405 to the 110 or whatever. And there's a great skit on SNL about that.
Oh, nice. Yeah. Here in Virginia, some of the roads are being renamed. Turns out naming them after Confederates is not a cool thing anymore. But like, I don't know the names of the roads to start with. People are upset about the change in some places. I'm like, I don't know. It's that road. Like,
right. Yeah. I grew up in the Northeast in New Jersey and obviously went to school in Boston. And a lot of that area is just numbered roads, and the exits are all numbered, which is amazing.
It's perfect.
Yeah. Some places don't do that. I don't know.
Yeah. No, I don't understand how numbered exits are not always a thing. But yeah, you say, so you're from Boston. You're so polite and nice, which is weird. I'm not used to that from
Jersey and Boston. You wouldn't expect it, right?
No. I've seen documentaries like Jersey Shore. So I feel like you're one of the good ones, I guess.
I appreciate it. My parents would love to hear that.
But yeah, so talking about your manufacturing facility, what's the biggest challenge to actually making these? Because as I would guess, this has not been done. We've made big ones that come back for people. This specific application is not a thing.
That's right. Yeah. The biggest challenge in general with the design and also the manufacturing is the miniaturization of all of the parts, right? So when you have a large vehicle, you can fit more capability in a larger space, right? So we need to fit that same capability in a much smaller space. So a lot of the work that we are doing is focused on volume. Most rockets are generally focused on mass efficiency, because that's really the big thing. We're very focused on volume efficiency. We are sometimes mass limited, but mass is mainly focused on the launch. For the reentry, we are relatively safe on the mass side of things. Manufacturing of very small parts, but also making highly optimized structures and propulsion systems and stuff like that enable a highly compact vehicle. Because the more space we have, the more customers we can fit on board. Most customers are generally volume limited for what we're working on. But there's some really cool benefits of being at the scale we are. One is that a lot of manufacturing methods are open to us that aren't previously open. So when you go with a 12-foot diameter capsule, right, the main aeroshell generally is going to have to be manufactured out of multiple pieces that are then welded together in some form. We're at the scale, especially for our smaller capsule, where we can look at single billet materials, where we're taking a chunk of aluminum, a chunk of stainless steel, a chunk of titanium, depending on the part, and actually machining an entire piece out of that. That generally isn't something that you want to do for high volume manufacturing, but it's really convenient for initial prototyping and initial design, because you don't have to build out an entire manufacturing facility to start manufacturing. There's some cool stuff you can do around 3D printing of parts. Where we're at the scale where a lot of parts can be 3D printed should they need to be. Not always the best way to go for us at our scale, just from a mass and from a complexity of manufacturing point of view, but a lot of cool stuff on the manufacturing side.
Yeah, no, and as you're describing milling these out of single pieces of metal, that sounds very similar. And so I looked at your woodworking sites. I would assume looks fairly similar to some of the pieces that you used to do in the woodworking.
Yeah, so it actually is a perfect analogy, and I'll start to get into the depths of woodworking terminology. So I'll try to keep it pretty high level. But when you're making a bowl, there's a couple different ways you can build a bowl. One of those is having just a block of wood where you put it onto a lathe and you use a variety of tools to gouge out the material. Right, it's effectively subtractive manufacturing, and where you're removing mass and you're molding a shape out of that piece of wood. And that is really tremendous for when you have beautiful pieces of wood, where they have incredible textures and incredible colors. Other ways, though, you can do it, and a lot of the pieces that I was really excited about is what's called segmented wood turning. So segmented wood turning is actually using small blocks of wood in a variety of patterns to build the skeleton of a bowl first. And then you just clean up the edges. So you can think of this as somewhat of an additive manufacturing process, even though it's not pure additive, but you are combining a bunch of pieces. That allows for incredible patterns and incredible things. Now, to bring it back to the segmented wood turning is the most efficient use of material, which means you're generally able to get away with a lower cost per bowl, for example. And that will be the same for large scale manufacturing for inversion, right? You want to limit the amount of material that you have to actually remove from a time perspective and from a cost perspective. But if you want to just make something quick and make it easy, you start off with a block of material and then you remove it. But yeah, a lot of similar design philosophies go into high-end woodworking as it does with high-end aerospace engineering.
Interesting. So when you're saying there's a lot of that cross application for people who either or professionally do woodworking, is there then a role for them in manufacturing, whether it's for companies like yours or other space companies that you've worked at or heard of?
Yeah, so I think that there's a lot of really transferable skills from a professional woodworker to a professional machinist, let's say. You're dealing with a lot of the same types of things. I would put it as, right, a Formula One driver can flex to being a rally car driver, or a rally car driver can flex to being a Indy car driver, for example, where a lot of the basic skills and kind of the touch and feel, the unquantifiable nature of the profession are the same, right? Hearing how a bit is vibrating when you're machining a part, and woodworking and machining is very similar. So I think if there are people that want to get into aerospace, right, demonstrating the ability to make things is a fantastic way to get a foot in the door.
Yeah, no, and now you've just given me another example to use when I talk with people, because we do a lot of workforce development stuff at the foundation, and I mention at community colleges, hey, if you can weld a wrench, you can weld a rocket. Now, I guess if you can machine a bowl, you can machine a return vehicle.
Exactly. Yeah. A lot of the things transfer. And I think you hit on a perfect point, right? On workforce development. I think that's something that's really important, not just on the engineer side, we need 10 engineers and that's it. Right. But there's, a lot of potentially a majority, depending on the company, of the workforce are non-engineers, right? Whether that be technicians, machinists, administrative side of things, and especially really high quality machinists and technicians are hard to come by because it's such a unique skill set to have. And building those, there's a lot of ways you can go about building them out, but they're really great careers and really high paying jobs that we're excited to be providing too.
Yeah, no, and I saw on you all's website, you're hiring, and your point about the workforce development, you can train an engineer in about 4 years. It takes better part of 10 to 15 to train a master machinist. We don't really think about that. We're like, oh no, go to school, get a college degree, kid. Maybe that's not always the best thing.
Yeah. I had deeply considered focusing on woodworking out of high school. That was something like people had kept talking to me about, like, hey, you have this like skill, you should think about pursuing it. On my side, I knew I wanted to get into engineering and I want to go down the entrepreneurship route at some point. But you're absolutely right. It takes quite a while to master these types of systems. And it's a lot easier to design a highly complex part than it is to make a highly complex part. So an engineer 4 years out of school actually likely will default to making a complex part rather than a simple part. But that means that it's very hard to manufacture.
Yeah.
And in most companies, the people that have the final say are the engineers. So it is on the machinists to a lot of times to help guide engineers in simple manufacturing. But I bet there's probably a really cool way that there could be like higher precision or more efficient ways to train machinists, technicians, stuff like that, such that we can compact that 10, 15 years into a rigorous 4-year degree. Imagine you come out after 4 years as a master machinist, you can make $150,000 a year or something in that ballpark, working on these incredibly advanced systems. I bet a lot of people would be really excited about that.
Oh yeah. No, I've talked with a handful of virtual reality companies who are trying to do just that sort of thing. Right now they're working with like police departments and some other ones, but doing that trades training is something they're looking to expand into, because if you put somebody in a room and they can do VR for 8 hours a day, practicing this, their hands are doing it, they have haptic feedback, like you can condense a lot of experience that way before they ever even touch metal.
Yeah, I think that's a fantastic future that we're going to have both for high school and for college and for postgraduate education. You take a high school, right? Maybe they're not comfortable having a automotive shop for liability reasons or for safety reasons or the space that they need. But there are a lot of getting that early experience is highly valuable. So if you can buy, a couple VR headsets, maybe totals $2,000, $3,000, which,
Yeah.
well, yes, a decent amount of money, especially for a lot of schools, is a lot less than setting up an automotive shop. But you can get a lot of the same learnings. You want to learn how to change the sway bar on a Miata, like you could probably do that through VR rather than spending the money on that actual car.
Yeah. And when you mess up, it's not awkward playing why you just broke a $10,000 part.
Exactly. Just hit the undo button.
Yeah, exactly. Yeah. And I mentioned this earlier. I looked at some of the woodworking you had done. Really good. So it doesn't surprise me at all that coming out of high school, people were like, dude, you're really good at this. You should do it. It looked like some of the stuff you did was almost by request or custom pieces. What was the coolest thing you ever got to?
So I think there are two pieces that I'm the most proud of. The first one is a rocking chair that I made in my senior year. I would spend too many hours a day working in the wood shop during school instead of going to class to build that rocking chair. And it's a Maloof inspired rocking chair with some of my own twists in it. And a Maloof chair, Maloof is a woodworker, basically pioneered a style of woodworking and a style of furniture, and is the most comfortable chair I have ever sat in. More comfortable than a bunch of pillows, more comfortable than a beanbag chair, because I literally molded it exactly to myself. And it's just an absolutely, that was something I'll have for the rest of my life. The other one is what I call the European decanter. So it's basically a segmented wood turned decanter. It has about maybe over 1,000 pieces, I believe. And that's actually in a private art collector's showpiece area in England, which is very exciting. Those were the most exciting. I always, whenever I would get a request for a piece, and most of the pieces I would do is just like self-inspired, just because I wanted to continuously one up myself. And I made this, I can make something better now. And for the satisfaction of the completion of something. But whenever someone would request a piece, I would always try to go like 10x above what they wanted. People wanted a cabinet, so I made them. I forget the style name right now, but I had like zebra wood inlays with all sorts of exotic woods. And I'm not sure it was profitable, but it was like beautiful, and it like made them incredibly happy. And I was going to make that part anyway for someone to be able to enjoy it.
No, that's a good point. And for our listeners, the Maloof chair, as near as I can tell from Google Images, appears to be the quintessential Americana rocking chair, but comfy. It looks like it's molded to the body rather than just being sort of that hard thing. And I guess Reagan and Carter were two people who had them, used them in like political ads and stuff like that for their Americana feel. They look like really nice chairs. And I really like the idea of it being molded to your body. That is pretty cool.
Yeah, they're fantastic. The backrests of them actually flex and pivot to like mold to your back.
That's amazing.
Awesome.
It's amazing. And I don't know that I've ever said that about a wooden piece of furniture, but that's impressive. Is there anything we, missed that we didn't talk about?
I think there's obviously plenty of stuff we can always go over. On Inversion side, we are an early stage company where we just raised our seed round, which is incredibly exciting, coming out of Y Combinator. And now we're scaling up, right? So the biggest challenges are ahead of us. And we're really excited to be executing at a high pace. There's nothing like working at a startup at our scale, where you have massive impact on the vision of the company, on the actual maturity of systems. When we re-enter our first capsule, it's going to be awesome for our engineers to say, hey, that entire thing, that's me. Yeah. That's that entire propulsion system, that entire structure, I did that, or had a major hand in. And so that's really exciting. And as you mentioned, we're hiring across the board and scaling up the company, really looking for tremendous engineers to work in a work environment. And there's a lot of great stuff happening on the commercial side and on the defense side that we're working on. I'm excited to share some cool stuff coming up soon.
Yeah, no, definitely going to need to have you back when you're announcing some of these deals that are coming up, because I can definitely see an exciting future here, and I'm definitely excited to hear about when the first recovery is going to be. Watch that. So that's going to be a huge milestone, and I'm excited to watch it.
Absolutely. Yeah, I really appreciate it. Yeah, thank you so much.
Yeah, thanks for being on here today, Justin.
Yeah, thank you so much. And thank you for everything you're doing in the community. It's really important, and it's awesome to have these advocates, people bring stories like you are, and we really appreciate it.
Gladly. Thanks, Justin.
Awesome. Take care.
Bye.